fundamentals of organic reaction mechanism. In last lecture, we have started this very important topic from the organic chemistry, and I must say this is the basic organic chemistry. This is the basic topic from the organic chemistry. Now, what we have studied in last lecture, introduction of reaction mechanism. Okay, now what is meant by reaction mechanism? Actually, in chemical reaction, there is a conversion of reactant into product, but it is not so simple process. That conversion of reactant into product may be involve formation of some intermediate. It may be involve formation of some intermediate, as well as that reaction takes place in number of steps. That reaction also involve breaking of some covalent bond and formation of some new bond. And that detailed information about reaction means how actually that reactant converts into product, what are the steps involved in the reaction, which intermediates are formed during the reaction, how the bonds undergo breaking, and how the new bonds are formed. And that detailed information about reaction is called reaction mechanism. In last lecture, we have studied what is meant by reaction mechanism in detail. Then in this topic, actually, we are going to discuss some important concept related to the reaction mechanism. And we have studied first concept, what is meant by curved arrow notations. Actually, in chemical reaction, there is a movement of electron, and that movement of electron is showed by curved arrow notation. There are two types of the curved arrows. One is a single-headed, and second is the half-headed curved arrow. If there is a movement of electron pair, then it is shown by single-headed curved arrow. And if there is a movement of single electron, then it is shown by half-headed curved arrow. It is also known as fish hook arrow. त्याला fish hook arrow असे म्हणतात. We have studied in detail about that curved arrow notations. Then second point which we have studied, types of bond breaking. This is very important concept. We know that to study the reaction mechanism, we must know what type of the bonds are breaking in that particular chemical reaction. Actually, in chemical reaction, each and every chemical reaction, there is a breaking of covalent bond, there is formation of covalent bond, and that breaking of covalent bond during the chemical reaction is called bond fusion. And there are two types of the bond breaking. There are two types of the bond fusion. One is the homolytic bond breaking, and second is the heterolytic bond breaking. Now, what is the homolytic bond breaking? Yes, it is symmetrical bond breaking. The symmetrical bond breaking in which each species acquire one electron from the shared pair is called homolytic bond breaking. We have studied with example and some properties of homolytic bond fusion. Then second, heterolytic bond breaking, the unsymmetrical breaking of covalent bond in which one of the species acquire both the electrons from the shared pair, and that is called as the heterolytic bond breaking. And here again we have studied with example and some characteristic points of that heterolytic bond fusion. Okay, actually this is the concept which we have already studied in last lecture. We have studied two important concepts, curved arrow notation and types of bond breaking. Now let us see next, again very important concept related to the reaction mechanism. What is meant by reagent and types of reagent. Okay, first we will see what is the reagent. Let us see a very simple example of organic reaction. Yes, this is the methyl bromide. Yes, that compound is the methyl bromide. Suppose that methyl bromide is treated with potassium hydroxide, KOH. Actually, this is ionic compound, potassium having a positive charge, OH having negative charge. Okay, this is the potassium hydroxide. When methyl bromide is treated with potassium hydroxide at high temperature, that reaction is carried out at high temperature. Okay, heating is there. Now, what happens in this reaction? In this reaction, that bromine from the methyl bromide is replaced by OH, right? And we get the methyl alcohol. Okay, now that bromine atom and that potassium, it forms KBr as a byproduct, while this is the methyl alcohol as a main product. Actually, what happens in this reaction? Methyl alcohol is the main product, methyl bromide is the main reactant, while this OH minus ion in this reaction, that OH minus ion attack on the methyl bromide, it attack on the main reactant, and then bromine is replaced by OH. Okay, now here this OH minus attack on the main reaction, and that species, that OH minus is called reagent. Means in chemical reaction, the species which attack on the main reactant is called as the reagent. त्याला आपण reagent असं म्हणतो. In this particular reaction, that OH minus ion attack on the main reactant, it attack on the methyl bromide. Therefore, that OH minus ion is called reagent. This is called reagent. Okay, thus in chemical reaction, the species which attack on the main reactant is called reagent. And there are two types of the reagent. One is called electrophilic reagent, or it is also known as electrophile, while second one is the nucleophilic reagent, or it is also known as nucleophile. Now, in this concept, we are going to discuss both the types of reagent in detail, what is meant by electrophilic and nucleophilic reagent. Okay, now let us see one by one. First, about the electrophilic reagent. First, tell me what is meant by reagent. Yes, the species which attack on the main reactant in a chemical reaction is called reagent. Now let us see first type, electrophilic reagent, or it is also known as electrophile. Now, before going towards the definition, that's a definition काय आहे ते सांगण्यापूर्वी I will explain some examples of electrophilic reagent. Let us see some examples of electrophilic reagent. Okay, these are the examples of electrophilic reagent. H plus ion, then H3O plus ion, then NO2 plus, NH4 plus, then here R3C, this is carbocation actually, carbon having positive charge, then NO plus. These are the examples of electrophilic reagent. Okay, now let us see some more example. यामध्ये आणखीन काही example मी तुमच्या समोर ठेवतो. Let us see in second line BF3 boron trifluoride, then aluminum trichloride AlCl3, FeCl3. Okay, then ZnCl2, then CCl2. Actually, this is carbon. याबद्दल डिटेल मध्ये नंतर मी सांगणार आहे. CCl2, then SO3 sulfur trioxide. These are the examples of electrophilic reagent. I have shown that examples into separate line. Okay, now what is the property of that example? First, tell me what is the property of that example. In first line, we have written some positively charged ion. They are positively charged ion. They having positive charge. Means we simply can say that yes, they are positively charged ion. First line examples are positively charged ion. Now, what's about the second line example? In second line, BF3, AlCl3, FeCl3, they do not having any positive or negative charge. Okay, means these are neutral molecule. They are neutral molecule. But that neutral molecule are having electron deficient center. That neutral molecule having electron deficient center. Now, what is meant by electron deficient center? म्हणजे त्याकडे इलेक्ट्रॉनची कमतर, डेफिशियन्सी मीन्स कमतरता. दे हॅव्हिंग इलेक्ट्रॉन डेफिशियन्सी. नाउ आई विल एक्सप्लेन. यामध्ये एक सिंपल एक्झाम्पल मी एक्सप्लेन करतो. हाऊ दॅट न्यूट्रल मॉलिक्यूल हॅव्हिंग इलेक्ट्रॉन डेफिशियन्सी. Let us see a very simple example. First one, boron trifluoride. How this molecule having electron deficiency? Okay, this is the boron actually. Okay, that molecule is having electron deficiency. Second line example. Now let us see example of BF3. Central atom is a boron. What is the atomic number of boron? Yes, 5. Its atomic number is 5. Then roughly I can mention its electronic configuration. In first shell there are 2 electrons. Then in second shell, there are 3 electrons, 2, 3. First shell having 2 electrons, second shell having 3 electrons. This is the rough electronic configuration of boron. Means from that electronic configuration, we can say that boron having 3 electrons in its valence shell. Boron having 3 electrons in its outermost shell. Suppose this is our boron atom. How many electrons are there in its valence shell? 3 electrons, 1, 2, and 3. Okay. Now, what is meant by octet theory? You must know what is the octet theory. According to the octet theory, atom should have 8 electrons in its outermost shell. Atom should have 8 electrons in its outermost shell. Then it becomes stable. फिरच तो stable होतो. Suppose it do not having 8 electron, मग तो काय करतो? Then that atom tries to attain stability. तो stability attain करण्याचा प्रयत्न करतो. Therefore it can share its electron with another, or it can lose electron, or it can gain electron. तो दुसऱ्याकडून इलेक्ट्रॉन घेतो किंवा दुसऱ्याला इलेक्ट्रॉन देतो किंवा दुसऱ्याबरोबर इलेक्ट्रॉनची शेअरिंग करतो. Okay, just to attain the stability. This is octet theory. This is octet theory. Now let us see about the boron trifluoride. In boron trifluoride, central atom is boron. It having only 3 electron in its valence shell, 1, 2, and 3 electron. Now what happens in the formation of BF3 molecule? Here, 1 electron of boron and 1 electron of fluorine. There is a sharing of electron and thus formation of BF covalent bond. There is formation of bond between boron and fluorine. 1 electron of boron and 1 electron of fluorine form 1 covalent bond. Similarly, another fluorine atom also having unpaired electron. That unpaired electron and electron of the boron form second covalent bond. Similarly, again one more fluorine atom share its electron with boron, and thus there is formation of 3 covalent bond. The 3 unpaired electrons of boron share their electron with the electron of fluorine atom to form 3 covalent bond. Thus there is a formation of 3 covalent bond. या पद्धतीनं 3 covalent bond तयार होतात. Now how many electrons are there in the valence shell of boron? आता बोरॉनच्या व्हॅलन्स शेल मध्ये किती इलेक्ट्रॉन्स आहेत? इट हॅव्हिंग टोटल 2, बरोबर. या इलेक्ट्रॉन पेअर पूर्ण 2 electron, this 2 electron and this 3 electron. We can say that it having 6 electron in its outermost shell. It having 6 electron in its outermost shell. Means again boron having 2 electron less to complete its octet. त्याचं ऑक्टेट कंप्लीट व्हायचं असेल तर त्याकडे किती इलेक्ट्रॉन असायला हवे? 8 इलेक्ट्रॉन असायला हवे. इट शुड हॅव 8 इलेक्ट्रॉन to complete its octet. But here that boron having only 6 electron after formation of covalent bond, means again it having 2 electron less to complete its octet. Means we can say that there is a deficiency of electron. This is electron deficient center in BF3 central boron atom having only 6 electron in its valence shell, and therefore there is a deficiency of electron. म्हणून मगाशी मी स्टेटमेंट दिलं होतं, similar to that BF3, all of these molecules are neutral and having electron deficient center, similar to BF3. In AlCl3, FeCl3, ZnCl2, there is a deficiency of electron. Okay, this is just about how they are having electron deficiency. Okay, मग मी पुन्हा एकदा आपल्या इलेक्ट्रोफिलिक रिएजंट कडे येतो. We have shown some examples of electrophilic reagent. यामध्ये फर्स्ट लाइन मध्ये आपण काय एक्झाम्पल दाखवलेले आहेत? इन फर्स्ट लाइन, yes, in first line we have shown some positively charged ion, while in second line we have showed some neutral molecules having electron deficient center. Okay, now how will you define that electrophilic reagent? Collectively आपण कसं डिफाइन करणार त्याला? Yes, the positively charged ion and neutral molecules having electron deficient center are called electrophilic reagent or electrophile. Okay, thus positively charged ion and neutral molecules having electron deficient centers are called electrophilic reagent. Very simple definition, and these are the examples of in question paper. You may always ask this question, particularly in objective. Okay, what is the example of electrophilic reagent? Dash dash is the example of electrophile. Okay, okay, this is just about the definition. Now let us see some properties of electrophilic reagent. यामध्ये पहिली property काय सांगता येईल? They are denoted as a E plus. Yes, they are denoted as E plus electrophilic reagent. Then second, electrophiles are electron deficient species. Yes, we have studied how they are electron deficient. There is a deficiency of electron. Neutral molecule having electron deficiency. There is a positive charge, means there is electron deficiency. Thus simply we can say that electrophiles are electron deficient species. Okay, second property. Then third one, they act as a Lewis acid. This is very important concept. What is meant by acid and base according to Levy's theory? We must know what is the Levy's theory. According to Levy's theory, the substance which can donate electron pair is called base. The substance which can donate electron pair is called base, while the substance which can accept electron pair is called acid. Now, what's about our electrophile? In our electrophile, there is a deficiency of electron. We have studied example of Br3, it having only 6 electron in its valence shell. It having 2 electron less to complete its octet, means there is a deficiency, and therefore that Br3 can be accept electron pair from another substance, and hence it act as a Lewis acid. All the electrophilic reagent having tendency to accept electron pair from another substance. Hence, they are examples of Lewis acid. Okay, this is the third property. Yes, they are Lewis acid. Then next one is the, yes, they are electron loving. Electron loving means they are having positive charge. What should about electron? Electrons are negatively charged. Therefore, there is always attraction between positively charged ion and electron. Means simply we can say that our electrophilic reagents are electron loving, and hence the name is electrophile. म्हणून आपण त्याला electrophile असं म्हणतो. This is about the first type of the reagent, electrophilic reagent. We have studied first definition of electrophilic reagent: the positively charged ions and neutral molecules having electron deficient centers are called electrophilic reagent. These are the examples of electrophilic reagent. Then some properties. First one, they are denoted as a E plus. They are electron deficient species. They act as a Lewis acid and electron loving, and hence name is the electrophile. This is about the first type. Now let us see second type of the reagent. What is meant by nucleophilic reagent? Here also, first I will explain some examples, and then we will go towards its definition. Okay, I will explain the first examples. Okay, these are the examples of nucleophilic reagent. I have written some examples: OH minus ion, Cl minus, Br minus, I minus, Cn minus, RO minus, NH2 minus, SH minus, and RCOO minus. These are the some example. While these are again some examples in second line: H2O, oxygen having 2 lone pair of electron, ROH, always oxygen containing compounds having 2 lone pair of electron. Similarly, thiol, this is alcohol, this is thiol. Sulfur also having 2 lone pair of electron. Then ether, right? Then ammonia, nitrogen containing having 1 electron pair. Then primary amine, secondary amine, tertiary amine. These are the examples of nucleophilic reagent. Okay, now let us see what are the properties of that example. What are the properties? What's about the first line example? In first line, we have shown some negatively charged ion. Yes, they are negatively charged ion. In first line, we have shown some negatively charged ion. But what's about the second line example? Now here also, they do not having any charge. There is no any positive or negative charge on that molecule: water, alcohol, thiol, ether, ammonia, primary amine, secondary amine. They do not having any charge, means they are neutral molecule. But what's about the characteristic property of that example? Yes, they having lone pair of electron. There is a non-bonded electron pair. Means simply we can say that neutral molecules are having electron rich center. That neutral molecules having electron rich center, म्हणजे त्याकडे इलेक्ट्रॉन रिच सेंटर आहेत, इलेक्ट्रॉनची त्याकडे भरपूर इलेक्ट्रॉन्स आहेत असं आपण म्हणतो. नाउ लेट अस सी क्वेश्चन, why that neutral molecules having electron rich center. Let us see how they are having lone pair of electron. हे जे इलेक्ट्रॉन पेयर मी दाखवलेले आहेत, ऑक्सिजन having 2 lone pair of electron, sulfur having 2 lone pair of electron, nitrogen having 1 lone pair of electron. They are also called non-bonded electron pair. Now question arises, how this molecule having lone pair of electron? I will explain simple example of ammonia molecule NH3, how it having lone pair of electron. Just for example, simple. Okay, let us see nitrogen. Central atom is a nitrogen. Its atomic number is a 7. It's atomic number 7. Then roughly its electronic configuration, first shell having 2 electron, while valence shell, second shell having 5 electron. Okay, now this is the nitrogen atom. How many electrons are there in the valence shell? 5 electron. First electron, yes, second electron, third electron, and again 2 electron. Total 5 electrons in its valence shell. Okay, now we know that according to the octet theory, that nitrogen share its electron with another. Now how it forms sharing? Okay, one hydrogen atom share its electron with the nitrogen, form covalent bond. Similarly, second hydrogen share its electron with nitrogen to form second covalent bond. Similarly, third hydrogen also share its electron to form third covalent bond. Thus, there is a formation of ammonia molecule, NH3 molecule, and NH3 molecule. But that NH3 molecule now having non-bonded, that two electron, these two electrons do not participate in the bond formation. They do not involved in the sharing. They are called as the unshared electron pair or lone pair of electron or non-bonded electron pair. Okay, this is non-bonded or lone pair of electron. And thus similar to that, all the nitrogen containing compound like primary amine, secondary amine, tertiary amine, they having one lone pair of electron, while sulfur and oxygen containing compound having two lone pair of electron. मी सर्व example explain करत नाहीये, just for convenience, just for your understanding, I have explained just one simple example of that ammonia, how it having lone pair of electron, how it having non-bonded electron pair. Okay, now here there is a lone pair of electron on the nitrogen, and therefore we can say that there is an electron rich center. Therefore we can say that there is a electron rich center. Okay, and this is just two properties of that first line and second line example. In first line we have shown negatively charged ions, while in second line we have shown neutral molecules having electron rich center. Then how will you define it? कसं define करेल आपण याला? The negatively charged ions and neutral molecules having electron rich center. The negatively charged ions and neutral molecules having electron rich centers are called nucleophilic reagent. Very simple definition. Okay, now let us say about the properties of that nucleophilic reagent. First, how they are denoted? Yes, they are denoted by Nu minus. Then second one, they are electron rich species. We know that they having negative charge. Negative charge means again there is electron pair, right? And also there is a lone pair of electron, means they are electron rich species. Second property, yes, they are electron rich species. Then third one is they act as a Lewis base. Okay, yes, they having lone pair of electron, and that substance having tendency to donate its electron pair to another substance. Therefore, they act as a Lewis base. Similarly, ions OH minus, Cl minus, again there is a lone electron pair in the negative charge, and it can donate this electron pair to another substance, and therefore here that Cl minus, Br minus, negatively charged ion, they are also act as a Lewis base, and thus that nucleophilic reagent having tendency to donate their electron pair to another substance, and therefore they act as a Lewis base. Okay, this is again important property. And last one, yes, they are nucleus loving. They having negative charge. Nucleus is positively charged. Therefore, they having attraction with the nucleus. Simply we can say that yes, they are nucleus loving, and hence name is a nucleophilic reagent or nucleophile. This is about the second type of the reagent, nucleophilic reagent. We have studied two important types of the reagent. One is the electrophilic and second is the nucleophilic reagent. Definition, then examples, and some properties of that particular reagent. Okay, very simple concept. Now let us see. This is very important concept related to the reaction mechanism. Means to study the reaction mechanism, we must know what type of the reagent is there, how that reagent attacks on the main reactant, and therefore to study the reaction mechanism, there is a necessary to discuss about that reagent also. Hence, we have studied that two important types of the reagent in detail.